This is probability problem number 11 from digital-university.org. In the last video, problem number 10, we introduced Bernoulli type probability problems, and we're going to continue working them in this video. I want to remind you that particularly with these videos here where we're dealing with Bernoulli probabilities, we're going to draw upon our knowledge from earlier videos that we posted concerning solving different types of combination problems and permutation problems, particularly when you have permutations with repeats, and how those type of problems can be reinterpreted as a combination problem. And if you're unfamiliar with those, if you go to the website at digital-university.org and click on combinatorics and probability, there you can find the earlier videos that we make reference to. Okay, for this video we have two problems. The first one is we have a single die, and if we roll it 5 times, what is the probability that the number 4 will turn up 3 out of the 5 times? And the second problem we want to consider is if we have a pair of dice and we roll them 3 times, and each time we add up the numbers, what is the probability that out of 3 rolls that they'll add up to the number 5? At least one time out of those 3 rolls. So I shouldn't say exactly one time, exactly one time. So I have a pair of dice, we roll them 3 times, we add up the numbers from each dice on each roll. What is the probability that on one of those 3 rolls, those pair of numbers will add up to be 5? Now, these are Bernoulli type problems because in the first instance, we're going to throw a die. If the number 4 shows up, that's a success. If it doesn't, that's a failure. And we're asking ourselves, if we roll it 5 times, what's the probability that the number 4 will show up 3 out of the 5 times? So here is the general formula that we developed in the last video. This is the probability for X number of successes. This is the number of trials. This is the number of successes. This is the probability of obtaining a success raised to the X power. This is the probability of failure, and that's raised to the N minus X power. Now, what we'll do is for the first part of the problem then, we'll just kind of plug in the numbers and get the answer, and then we'll go back and see if we can make certain that this formula makes sense for what we just did. So here we want to know what is the probability of having 3 successes, and a success is defined as the number 4 shows up when you roll the dice. Now, of course, the dice has 6 sides, and only one side has 4 dots on it, so only one side is going to manifest the number 4. The probability of that happening is 1/6. So P for success is 1/6. We'll talk about this in a minute. And we say we want to know if that's going to happen 3 times. So that would be cubed. Failure would be 5/6, 1 minus 1/6, which is 5/6. And that's squared. And this is C, this is 5, and this is 3. So here, let's look at this. This is the number of successes, 3, 5 trials, 3 successes. 5 trials, the number 4 pops up on 3 of them. The probability of getting a 4 each time you roll it is 1/6. We're doing it 3 times, so it's 1/6 cubed. Failure is when you don't get a 4. That would be a 5/6 chance of that, and the exponent that failure is raised to is this minus this, and minus x, or that squared. And this here then is just the binomial coefficient 5 over 3. So this right here will give us our number. This is 5 factorial over 3 factorial times 2 factorial. And let's see, here we have 1 times 25 over, and here we have 6 to the 5th power. And this is going to be 5 times 4 times 3 factorial divided by 3 factorial times 2 factorial, which is just 2. So that's 2. So this is 10. So the probability then of having the number 4 show up on 5 rows with a single die is going to be 10 times 25 over 6 to the 5th. Or that's 250 over 6 to the 5th. I think if you put it on the calculator, that's around 0.032. So you have a single die, you roll it 5 times, the probability of having a 4 show up 3 out of the 5 times is 0.032. Now let's go back here and look at our formula, what we did. We know that when we roll the dice, the probability of having a 4 come up is 1 out of 6, and the probability of not having a 4 come up is 5 out of 6. So we're saying, well, suppose then that we roll the dice, we're doing it 5 times. Let's just suppose the first 3 events are success. And that would mean, of course, then the last 2 events are failures. Like this, and the probability of this happening, these are all independent events, so it'd be the probability of success times itself 3 times or cubed, and the probability of success is 1/6. Success is when the number 4 shows up, so this is 1/6 cubed times this is failure and this is failure, multiply them together. These are independent events, and we have that. But you see, we could also have it where perhaps the first throw is a failure. And then that is followed by, then in other words, a 4 does not turn up. That is followed by a success, say followed by a success, followed by a success, followed by a failure. Now the probability for this event, it's the same thing. This times this times this, 1/6 times 1/6, 1/6 cubed, 5/6 squared. The question is, how many different variations of this can we have? In other words, this would be the 4 shows up, 4 shows up, 4 shows up, 4 shows up, then you get a non-4, and again a non-4. How many ways can that happen? Well, that's the combination then. Like this. Here there are 5 symbols here. How many ways can we permute those 5 symbols? That's what we're really asking ourselves. And here, that would be, well, 5 factorial, the total number of them, divided by the repeats. This one is repeated 3 times. this one is repeated 2 times. So this is a permutation with repeats, or it is also this binomial coefficient. So when we were going back up here, hopefully it's clear where these came from, and now hopefully also it's clear where that binomial coefficient came from. So that's the formula that we derived in the past video. Here's how we applied it to this problem, and hopefully what we just did kind of brings more sense to the formula. Now, we have the second part of the problem here. And that is where we roll 2 dice. So let's see. We have 2 dice. We roll them 3 times. Each time we record their numbers and add them together. When we do that, what is the probability that out of the 3 rolls, they add up to the number 5 one time out of those 3 rolls? So the first thing I have to think about is, if we roll 2 dice, we could get a 1 and a 4, the first roll and the second roll, or we could have a 2 and a 3, or the first roll could be a 4 and the second roll could be a 1, or the third roll, or on the other time that we do it, the number 3 might show up on the first roll, and the number 2 shows up on the second roll. So there's 1, 2, 3, 4 ways that the number 5 can be obtained from these pair of numbers when a pair of dice is rolled. So there's 5 ways, or there's 4 ways to get the sum of 5. Now when you take 2 dice and you roll them, how many different numbers combination can you get total? Well, task T1, the first dice is thrown. That can have 6 possibilities. For task T2, the second die is thrown. That can have 6 possibilities. So when you perform task 1 and then task T2, the total number of possibilities by the counting principle is the number of ways this can occur times the number of ways that can occur, which is 36. So when we have a pair of dice and we roll them, there's 36 possibilities. And that would be 36 pairs of numbers that we could get. 1, 2, 3, 4 of them can add up to the number 5. So the probability of our success is 4 out of 36, or 1/9. So when we throw the pair of dice, the probability of having it add up to the number 5 is, the probability of that is 1 out of 9. Okay, so the probability of success is 1 out of 9, and the probability when you throw the pair of dice and they don't add up to number 5, that would be 1 minus 1 over 9 for the failure, and that would be 8/9. So here this is the probability of success, and the probability of failure, 1 minus s, is 8/9. Get this in better focus. Okay, now we're ready to go ahead and apply our formula. Success is when you throw the pair of dice and the pair of numbers add up to 5. Failure is when they don't. And the problem says we roll it 3 times, so there's 3 trials. How many times then will the pair of numbers add up to 5? Exactly once. So here then, the number of successes is just 1. So the probability of 1 success, that is having the numbers add up to 5, that is equal to the number of trials, that's 3, the number of successes, that's 1, So that's this times the probability of success, that's 1/9, to the first power, because we're only looking at one success, times 8/9 to the 3 minus 2 squared. So this then would tell us the probability of having the pair of numbers adding up to 5. So here we have, this is 3 factorial over 1 factorial times 2 factorial times, here then, this is 9 times 9, that's 81 on the bottom. Nope, this is 9 squared times 9, that's 9 cubed, and here we have 8 squared, that's 64. So here this is equal to 3 factorial divided by 2 factorial, that's just 3. So we have 3 times 64 divided by 9 squared times 9, that'd be 9 cubed. Those cancel, so we have 64 over 81 times 3. 8 times, that'd be 64 out of 243. So when we have a pair of dice and we roll them 3 times, so there's 3 trials, the probability of having those pair of numbers add up to 5 in one of those trials is 64 out of 243. And again, hopefully now the formula is starting to make more sense to you. Here, for this problem, it might be that on the very first row they add up to 5, so there's our success, and then for the other rows they don't add up to 5, those would be failures. And the probability of this event happening is the probability of this, which is 1/9. This is 8/9 times 8/9. So here we have our 1/9 times 8 over 9 squared. Or it might happen like this. The first event might be a failure. When you throw the dice, the pair of numbers do not add up to 5. The second number is a success. And the third trial is a failure. Or it might happen like this. The first one is a failure. The second trial is a failure. And during the third trial, they add up to the number 5. And of course, the probability of each of these are all the same. This is 1 over 9 times 8 over 9 squared. Or in this case, it is 1 over 9 times 8 over 9 squared times 3, which is what we got from this. And this really is, what we're saying is, here we have a 3 that shows up on the first trial, and then it does not show up on the next 2 trials. How many ways can we permute this? Well, there's 3 ways. We just showed what they are. But again, the formula would be the total number of letters divided by the repeats, which comes out to be 3, which gives us this part of the formula right here. So that's it. Hope that makes sense. Come back and join us for some more videos, and we'll try and solve some more problems.